Are you Post Malone? Nice. That's a good one.
Yeah, I've done many concerts so far.
to start class today, I need y'all to get out that handout from last time, number 45.
Don't look at that guy. Don't look at that guy.
Okay, so after our quiz last class, we started the 4.8 notes, practice, homework, all of that rolled up into that one handout. And we did a few of the questions together, but I'd asked you to finish up the rest of questions 1 through 15. Those were either pretty basic word questions or just generic find the side, find the angle of a right triangle, which is what we're going to need for the more complicated applications. So this is a pretty short unit. This is our one full class period on it, and we will have a quiz over these question types next class. So first off, I'm going to give you a chance to ask questions on the 1 through 15. So if you had trouble with any of those as part of your homework, you're going to have trouble with the same thing on the second half of it. So we need to clear those up first. Then we'll go question by question on the remaining ones, and there's not a lot of them, so we have time to let you try them and time to go over every one of them individually. Okay, so about half the points will come from questions like 1 through 15 on your quiz, and then about half the points come from questions after 1 through 15. So was there any 1 through 15, any of those you want to go over before we move on? Any of the homework questions that you had trouble with? Yeah. 13? Okay, was it this angled part? Yeah. Okay, so this will come up in later questions, so it's good that you asked if you don't remember. But this is something we did the first week of school called degrees, minutes, and seconds. So you need to know how to change this to a decimal. So 12 degrees is 12 full degrees. And you have to remember that a minute is a 60th of a degree. So when you type that into your calculator, that's the same thing as 12.25 degrees. You need to know how to change that over to a decimal. And then it should work out as like the other ones. So I will let you finish. Okay, other questions about 1 through 15? Okay, then let's move on to number 16. Now again, we don't have a lot of questions here. 3, 4, 5, 6, 7, 8. There's 8 questions total. And these are the question types. If I just go over them with you, it's not going to be as impactful. It's not going to help you as much as if you try them on your own first. So what I'd like you to do is go ahead and read question 16. Try it out. Try to get the final correct answer. At the very least, get far enough to know where you're getting stuck so you know what information you're lacking to keep you from finishing that question. So I set a timer, and I give you about 4 minutes to try 16. Now, if you get an answer and you think you're done, go ahead and move on to 17. Or if you get stuck on 16 and you know there's nothing else you can think of and you're going to have to wait for me to go over it with you, then same thing, move on to 17. So make sure you're being productive with your time, but give 16 your best effort, please.
5 minutes.
Oh, it's 40. Did we start at 30? No, we started at 35.
Also, are you done with this question?
No, I'm not. I'm gonna pull my phone book.
Now, of course, you guys can pull up the solutions on the website, but I will also.
I was gonna do that actually.
Oh, that's fine too. But I'm also jot the answer down to number 16. So when you finish, if you have that as an answer, that means you figured out what you needed to do, and you can move on and not wait for the rest of us.
Is this 46 or 45? Should be 45. It's fine, actually.
Yeah, I got 45.
Here you go. Welcome.
All right, that was actually 5 minutes. So if 5 minutes was not enough time, then maybe something held you back. But if you think you finished, you need to have this answer that's almost 30 feet. If you didn't end up with that, you need to follow along and see what you should have done differently. Okay, this one, as well as several other of these last 8 questions, you do need to make a picture. So yesterday when we were doing this in my 8A class, I kind of went around to see what people were doing, and there was a lot of right triangles, which is good, but you need a picture. Sometimes people would say, does my triangle look correct? And I couldn't tell what they thought the library was, where they thought the flagpole was, so I couldn't even give them a yes or no. But you should draw a library. It says flagpole is mounted on the front of the roof. There was a point 100 feet in front of the library. Then there was an angle 28 degrees to the bottom of the flagpole and a bigger angle 39.75 degrees to the top of the flagpole. That's the picture that you needed to get out of it. So in the end, we are going to be able to figure out how tall this flagpole is with just SOHCAHTOA skills. Now, it might be tempting to try to use this slim little triangle here, but again, this is not a right triangle, and every trig thing that we have learned so far is considered right triangle trig. Pythagorean theorem is great, only works on right triangles. SOHCAHTOA is good for finding side angles, but it only works on right triangles. Inverse SOHCAHTOA is good for finding angles, but it only works on right triangles. You should not be using this slim little triangle here. But what you could do is you could use this smaller right triangle to find the height of the library with a tangent equation. Tangent because it pairs up opposite over adjacent. It looks like the height of the library is 100 tangent of 28. And then there was a second right triangle, this one that I have in purple, and I will call its length x. You could also solve for x, this whole thing, by doing the tangent of the 39.75 degree angle, because that puts opposite x over adjacent 100. And then what makes this question different than the first 15, the reason why I didn't ask you to do this one for homework, is then at this point you had to think about how to put these two together. If you know this whole length, x, and you know how much of it is not the flagpole, h, x, take away how much is not the flagpole, is going to leave behind how much is the flagpole. That's where the 29.998 feet come from. So don't be tempted to try to use a non-right triangle. And for this one, you had to do it twice and then understand why you needed to subtract those. Okay, does everybody see how to move past where you got stuck if you didn't get that as an answer? We're good to move on? Okay, 17 should be a little bit quicker of a question, so let me give you a couple minutes to try it, but I'm not going to give you 5 minutes on this one. We'll just do 2 or 3. So if you've not tried 17 yet, please do it. And if you don't end up with an answer of $38.290 degrees. If you don't end up with that as an answer, then you'll need to follow along with this when we go over it. Okay, I feel like 17 you should be finished up with. So again, if you did not get this as an answer, make sure, first let's make sure your picture looks okay. So 75-foot tower, and there's a point 95 feet away from the base, and you were tasked with finding the angle of elevation. So angle of elevation is from a horizontal line measured up. So they were asking you to find this angle right here. So you've got a right triangle, so SOHCAHTOA, Pythagorean theorem, inverse SOHCAHTOA, all that stuff is fair game. So what you probably would have done a few weeks ago is said that tangent from that angle is opposite over adjacent. But in last section we kind of focused on to go from tangent theta equals to just theta equals, you do inverse tangent. So the quick summary is, if you're trying to find a side length, you should be using regular trig functions, sine, cosine, tangent. But if you're trying to find angle measures, you should be using inverse functions. Inverse sine, inverse cosine, inverse tangent. Okay, any follow-up to number 17? Any other parts of 17 I can help with? Okay, then on 18, let me give you one little tip here. Because in mathematics we generally don't assume anything. You should never really assume. But in 18 they do expect you to assume something here, and they don't give you really enough information, I think, for you where you should be doing that. And that is that this and this, these two together make a right angle. So they don't make that very clear, but they expect you to assume that. So try 18. 18 has a very common mistake in it. A very common place where students make a careless mistake. But in the end, this one should end up being 75.920. So take a couple minutes to see what you think you need to do. Is it supposed to be 9.7? Let me check again. It is supposed to be 9.7, sorry. Okay, one more minute. And again, I think I'll know where most of your mistakes are. If you're getting an answer that's close to that, but not that, it's probably going to be a pretty easy fix. But this is something that could be fair game for Thursday's quiz, so we need to make sure you get it. So if you did not get that as your answer in number 18, they were asking for this angle of depression, which they labeled for you. So it's the part of this right angle that's not this angle in the triangle. So your answer should come from 90 degrees minus whatever this angle is. And then that should give you your answer. So you go to find this angle, just like we did in the previous question. And the most tempting thing to do is to say, I'm trying to find an angle. So that's inverse. I know opposite and what is this? So that would be sine. And you're going to want to say opposite is 4,000 and hypotenuse is 12,500. But the hypotenuse is not 12,500. 12,500 is from here to here. It's not the whole hypotenuse. So how am I supposed to know how much this is then?
16,500.
This is 16,500?
Oh no, that's 4,000.
Okay, how do you know that's 4,000?
Because the radius is 4,000.
Right, so the radius is still the radius. So the hypotenuse is actually 16,500. And that's a very common mistake for students. So that's what you should have thrown in your calculator to know how big that gray angle is inside the triangle. It's about 14.030. And your answer was supposed to be the complement of that. So 90 minus that comes up with that angle. So for most of you, I think you need to just check this. If you said the hypotenuse was 12,500, you just need to be a little bit more careful. That was just part of the hypotenuse. Okay, anything else specific about 18 that you need some help on? Okay, then go ahead and read 19 and see if you can come up with that as an answer. Okay, so one of the things about this question 19 that may have held you back is also going to show up in question number 20. So if you start to draw your picture, you should have a runway, your plane's taking off in the air here. We'll just pretend like this looks like an airplane. You know it's climbing at 18 degrees. You know the speed of the plane is 275 feet per second, and you're trying to find altitude. So altitude would be how far away you are from the ground. I'm going to call that capital A. Now, if you start with this and you try to find this side with the SOHCAHTOA equation, do you see why this answer, if you do it right now, this answer is going to be less than 275? Do you see why that would have to be the case? Because hypotenuse has to be biggest. So here's what you may not be considering if you're doing that. Altitude, this is supposed to be a length or a distance. It's supposed to be so many feet in this question because this question is about feet. This 275 is not a length. You need to be consistent. You can't label this as a speed and then expect this to come out as a distance. If you want this to be a distance, you need this to be a distance. So don't call this 275. It's 275 feet per second for 60 seconds for 1 minute. So if every second he does 275 feet, then after 60 of those, he has done 16,500 feet. Now that this is a length, and I want this to be in the length, now this matches up with the generic triangles you did for homework. You could do sine, because we want to find opposite when we know hypotenuse. So the answer, altitude, should come from 16,500 times the sine of 18 degrees. That's what should give you that as an altitude. Yes?
This might have been a rounding problem, but I made it 5,100. Would you take that?
Based on how this question's worded, I guess, but 99% of the time we ask you to round to 3 decimal places. So if we ask you to round to 3 decimal places, you would at least lose a point for rounding. And I may have mentioned this, but I know if I have, it's been weeks. We pretty consistently always ask for 3 decimal places because if you choose to go on to AP Calculus next year, on that AP exam, they expect you to round to 3 decimal places all the time. So they don't even put that in the directions. It's just understood you're supposed to know to round to 3 decimal places. So if we make that a habit in this class, then that's one less hurdle that you have to worry about for calculus. But, okay, anything else about number 19? Okay. Then, before I give you a few minutes to try question 20, for those of you that haven't yet, I need to tell you a couple things here. There's 2 things that don't really make a difference, but you need to know that they don't make a difference. And then one thing I need to remind you of. So, number 20 is about a ship, and it says that he sails at 20 knots. 20 knots is 20 nautical miles per hour. When it wants you to find nautical miles basically mean miles in the water, but it's actually not a 1-to-1 ratio. A nautical mile is like 1.018 land miles or something. But you don't need to know any of that. It doesn't matter. You can just pretend like this says miles, and you can pretend like this says 20 miles per hour, and it works out fine. It all balances out. So the other thing is, when we did our notes last time, I said there was one geometry thing that's going to make one of our questions harder on the second half, so that hasn't shown up yet. But also, the only 100% new thing in this section is bearings. You need to know what a south 29 degrees west bearing looks like. So, if we look at the notes we took last class for a few examples, here's what a north 30 degrees east bearing looks like. We started from the north line and turned 30 degrees towards the east line. East 20 degrees south would start at the east line and measure 20 degrees towards the south line. south 45 degrees west would start at the south line and turn 45 degrees towards the west line. And then you had tried starting at the west line, turning 15 degrees up towards the north line. So being able to sketch that and label that angle where it's supposed to go is one of the pretty much the only new thing in section 4.8. So I still want you to give it a shot to see what you think and see how you do. So if you've not tried 20, please go ahead and start now. This one you should end up with 2 answers. And I'm going to jot both of these on my paper so that you know if you can move on. When you finish. it's 5 minutes. So at this point, you either got those or you should know where you're getting stuck. So let's help you get unstuck here. So you need to make a picture. You know your picture needs a right triangle because that's what we're focused on. But with this bearing, it says that your ship is leaving a port at taking this bearing. So you should have one point that is your port. I think it's probably important that you label it as your port. And then starting at the south line, turn 29 degrees towards west. That's what that bearing needs to look like. You need to make sure you put the 29 where you think it goes to. Okay, and so there's not a right triangle here yet, but you were asked how many nautical miles south did they travel? So that would be that. And then how many nautical miles west did they travel? Which would be that. And of course, south and west are going to be perfectly perpendicular. So at this point, it was just two SOHCAHTOA equations. Yes, Jack, do you have a question?
I thought we drew it to the x-axis.
That's a reference triangle. This is not a reference triangle. You have to draw it however this tells you to. Okay, so to find the south, I could do cosine because that puts adjacent over hypotenuse. Now, I guess I didn't put this here, but this guy is going 20 knots. Now, like the last question, that's a speed. If you want this to be a speed, that's fine. But if you want this to be a length or a distance, you need this to be a length or a distance. So you should not be calling that 20. He's going 20 knots for 6 hours. He started at noon and at 6 o'clock. So 20 times 6 gives you 120 nautical miles. You need this to be a length if you expect these to be lengths. So my south answer came from 120 times the cosine of 29 degrees. And then the west answer, I would use sine instead. Because sine lets me pair up opposite over hypotenuse. So the distance west that they traveled is 120 sine of 29 degrees. Which gives you that. Now, you may not think this is very interesting, but I do. So notice what I typed in my calculator for these two. The only difference was sine versus cosine. So cosine did a good job of helping us find the distance south we traveled, whereas sine helped us find the distance west that we traveled. So literally the only thing different about those two equations, but they're measuring very different things. So, okay, any follow-up to question 20 to help you come up with those answers? Okay, then let's move on. So we've only got 3 more questions, but I will warn you, 21 and 22 are typically the ones that students find to be the hardest. So I do want you, I'm not going to give you a ton of time for question 21 because I think it would be very, very difficult for y'all to get this without a hint. But take a couple minutes, and this one is asking for 2 things. Part A is not too bad, but part B is kind of tough. But see what you can do in the next couple minutes. I'm going to stop you, which I realize is probably not enough time for most of you, but most everybody's going to need at least one hint for part B. So, reading through here, there is some stuff that they give you that they did not put on the picture for you, such as the bearing from A to B is north 32 degrees west. So that means if you were standing at point A and you wanted directions to head to point B, you should start at a north line, which is not drawn in for you, and then turn 32 degrees to the left, because that would be turning towards west. That doesn't mean that angle A is 32 degrees. In fact, we know angle A is 90 degrees. But from the north line, 32 degrees towards the west line, we know how much of this angle A is going that direction. Seems kind of irrelevant at this point, but it is needed. They also tell you that they walk 50 meters, but they put that on the picture for you. And then the other bearing is from C to B. So if you were standing at C and you wanted directions to head directly towards B, you could start at a north line and turn 68 degrees towards the west line. So you need to understand bearings well enough that you can add those angles to your picture. Then part A wants to know, or wants you to write a bearing from A to C. So if I'm standing at A and I want to head directly to C, I could start at this line, the north line, turn to the right, which would be towards the east line, and then how much should I turn? How much is this going to be? 58. So if we know this is 90, and then indirectly they told us this much of it was 32, then the rest of this must be its complement. So that's why they were giving you that 32. From the north line, 58 degrees towards the east line. That's what they're looking for in part A. Now, part B wants us to find the distance from A to B. So basically how far along, or how far or wide is this swamp, which is a pretty hard thing to measure physically, so it's kind of nice to just do this with a few angles. Okay, so before I just say do this, then do this, do this, do this, and then here's your answer, we kind of need to backtrack. We're trying to find a side length, so just like questions 1 through 15, there's only 2 ways to find side lengths. Pythagorean theorem, but I would need to know both the other sides. I know this length, and finding this length is probably just as much work as finding that length, so it seems like Pythagorean theorem is not an option. And then the only other way to find an angle is with SOHCAHTOA. SOHCAHTOA can get you a side length as long as you know another side length and one of the acute angles. Unfortunately, I don't know how big angle B is or angle C, but I know nothing about what's going around B, so I'm going to seek out and try to figure out how big angle C is. Because if I figure out how big angle C is, I can do a tangent equation. Tangent of that angle is equal to opposite, which is what I'm trying to find, over adjacent, which is the 50. So that at least gives me something to aim for. If I can figure out how big this angle C is in the triangle, I can plug it in, and my answer will be 50 times the tangent of that angle. So we've got the bearings listed on there. We found one other angle on here, but for me to find angle C, this is what I'm hoping that you discovered when you were trying this on your own, that you kind of hit a roadblock. You can't just subtract from 180 because you don't have 2 of 3 angles of any one of these triangles, small triangles or big triangles. At some point, you're going to realize you don't have enough angle information. So, what makes this question unusually difficult is we have to use an old geometry thing. So, I tried not to give you any hint on that today, but we talked about it last time. If you look at angles that are sandwiched in between two parallel lines, the angles that alternate, like 2 and 4, top left, bottom right, or 1 and 3, top right, bottom left, if they're alternate interior angles inside of two parallel lines, they have to be the same size. This is the trick that's going to help you get one more angle out of this question. So, back to our picture. Okay, it's being fussy. Okay, on our picture, do we have parallel lines anywhere?
Norths.
Very good. So these bearings, a north line and a north line, they're certainly going to be parallel. So there's your two parallel lines. Now it is kind of tilted from how you're used to seeing it. In geometry, you get kind of spoiled where it's always like that. The two parallel lines are always on top of each other, but this time they're like kind of slanted, so I guess you can turn your page if you want to. But here is a transversal. Transversal is just a line that intersects two other lines. But this 68 is in the interior, it's inside the two parallel lines, and he alternates with this one. Because he's in the top right, he alternates with the bottom left. So if this is 68, this has to be 68. Because of alternate interior angles. So if you can get that extra angle on there, then it's a whole lot easier. Because now we can find this angle, because we know 2 of 3 of this triangle. So subtract away the 68 and the 58, tells me that angle C is 54 degrees. And now that I know angle C is 54, that was really the last domino to fall in this question. Our answer should come from 50 times the tangent of 54 degrees. 68.819 meters. So I'm sure that you could identify and work with alternate interior angles in geometry class. You just have to try to apply that here. It's a little harder to see because there's more stuff going on. But typically we'll ask you to do that at least once on the quiz. So if you know that you don't have enough angle information, if you've got two parallel lines, try to find alternate interior angles. And it should be a little bit easier too, because not only are these the same size, but they should look like they're the same size. If you try to say like this one is 68 and this one's 68, like this looks like an obtuse angle. So that's probably doesn't make sense. That's probably not 68 if it looks obtuse. So we've got some hints there. But alternate interior angles is how I progress. Okay. Anything else about that one? Okay, let's look at 22 together. So unlike the others, this is the only one I'm going to ask you or say that I don't want you to start it, because depending on how you start it, your work could be close but still be a little bit off. So this one is challenging for a different reason. It's a good algebra exercise, but I will try to show you why this is important for calculus, for those of you going on to calculus next year. So this question says we've got two fire towers 30 kilometers apart. There's a couple bearings, but they put the bearings in the question for you, so that's not a problem. They want you to find this distance D. So they don't really explain it, but I'm guessing that this is probably a road and you're trying to find the distance, like how far away the fire is from the road or something. So that's what we're trying to find. Now for this question, again, you need to be hyper focused on right triangles. So there's a right triangle here on the left that I could say the tangent of 14 degrees is equal to opposite over adjacent. Now, is this length 30? No, 30 is the whole thing. So, since I don't know how much of 30 this is, I'm going to call it x. Tangent of 14 is opposite over adjacent, d over x. Now, the problem with this is you know that you can't solve an equation that has two variables in it. But if I multiply both sides by x, I can see that if I can ever figure out how big x is, d is going to be x times the tangent of 14. So that's where my final answer is going to come from. Okay, luckily we have a second right triangle, otherwise we'd be stuck. So from the 34 degrees, looking at this right triangle, I could do another tangent equation, and I could say tangent is opposite over adjacent. Well, how big is the adjacent side? Very good, 30 minus x. So you might be tempted to call it y. It is also an unknown, but you can be more specific. If this whole thing is 30 and some of it has been designated x, the rest of it is 30 minus whatever x is. Once again, I can't just solve this for d because it's got two variables in it. But if you can come up with two equations like this one and this one that has two unknowns, we can solve this with a system of equations. So you learned how to do system of equations in Algebra 1. You learned lots of different methods, graphing, addition / elimination, and substitution. And then, did y'all do matrices last year in Algebra 2? You did? Okay. Did you solve system of equations with matrices? Like 3 variable systems? No? Okay. Well, if you did, that's a possibility too. But that's not what I'd want you to practice anyway. The one I'd want you to practice is substitution, because that's the one that we use 99% of the time in higher mathematics. So substitution says solve this one for d or x, whatever you want, or solve this for d or x, whatever you want. I'm just going to use this one because I've already done it. D is x times the tangent of 14. So it's called substitution method because you start off by substituting this in. So instead of saying d, I'm going to put x tangent of 14 degrees. And this one is going to be a challenging algebra problem, but notice with that substitute, you have to understand why each one of these steps is better for you to hope to do it yourself when you're on your own. But this is much better than what I had because at least this only has x's in it. So in theory, after a few algebra steps, I can solve this for x, and then once I know what x is, I can plug it in over here and give d, which is what they really want. Okay, the first thing that I would do on this question is I would multiply both sides by 30 minus x. The reason why I think that is helpful and why I know to try that is because now at least I don't have fractions. That's an improvement. Solving an equation with fractions, it's always easiest if you just get rid of the fractions first. Remember, this is just a number, so next up I'm going to distribute this. And the reason I know to do that is because now I don't have parentheses. So that's still progress. Okay, for our next step, what is it that we always have to do if we're trying to solve for x? Okay, you need one side to have all of your x stuff. So I'm going to add this over. And you want one side to have all the other stuff. In this case, just a number. 30 tangent of 34 is just a number. So that's referred to as isolating x, getting all the x's on one side. Now, this is a step that, I don't know, even in calculus, they struggle seeing this sometimes. To me, this is really obvious, and it's probably honestly, the easiest algebra thing you've ever learned. But if you don't see to use it yourself, then it's not real useful. Now, if this had said something like 8x's plus 2x's, I could use like terms and combine those to make 10x's. But this is some weird decimal number of x's, and this is some weird decimal number of x's, and I don't know what that is. So, any ideas on how we could try to move forward?
Divide by x.
No, not divide by x. Something.
Combine the tangent 34 together.
This tangent 34 and this tangent 34?
Maybe? Yes.
They're on separate sides of the equation, so.
We can combine tangent 14 and tangent 34 and make it x plus x plus tangent of 48.
That's not the same thing as x times tangent of 14 plus x times tangent of 34.
Could you divide by tangent 34 or tangent 14?
That's part of what you need, but not all of it.
Do you divide by both?
You divide by both of them with a math symbol in between them. You guys are making this way harder than it has to be, but you're proving my point that you can do the algebra skill, but you don't see what to do. You see this term and this term? What do they both have in common?
Like
X.
So, the algebra thing that I'm referring to is GCF. If both of those have an x, you can factor it out. And then the thing we're trying to find is being multiplied by a big number. How do you undo multiplication? Divide. So it's messy looking, but we're just undoing division. So it looks like x is 30 times the tangent of 34 all over the tangent of 14 plus the tangent of 34, which is about 21.904. And you're going to be tempted to circle that as your final answer, especially because you're not used to questions being that long. Usually if you work anywhere near that long, you're to your answer. But again, be careful. This question could care less about what we called x. It wanted to know d. But now that I know what x is, I had set up over here that d is just that times the tangent of 14, which gives us the 5.461 kilometers. So, just based on the information I had, we started off with two SOHCAHTOA equations. The only way to solve two variables in two equations is, that's called a system of equations. And we don't have to do that all the time in calculus, but we do have to do it sometimes. So I solved this one in terms of d, substituted it in here. It gave me an equation that only had x's in it. I multiplied both sides by the denominator, so at least I didn't have fractions. I distributed this number, so at least I didn't have parentheses. I got all the x stuff on one side because I knew I had to do that eventually. This had x's, so I could factor it out with the GCF. And then finally, I could undo times with divide. Once I knew how big x was, I could make my second substitution over here to figure out how big d is. So that one's a pretty good algebra workout there. And to see if I still have it saved. Okay, so this was just for reference, not that you guys are too worried about this, but probably about 2 weeks ago, maybe 3 weeks ago in calculus, we were doing a practice FRQ, and you don't have to understand this first step or how they got that, but this first step was really the only calculus. The highlighted parts were the calculus parts. But then notice that you distribute this negative like so. We were trying to solve for this y prime thing, so everything that was y prime I put on one side, everything that was not y prime I put on the other side, just like the question we just did. Both of these had a y prime, so we have to factor it out as a GCF, just like we did on this last question, and then you undo times with divide. So very similar algebra work, and that's just one of 3 parts of FRQ for calculus. So that in calculus, by far, it's not usually the calculus concepts or calculus material that's difficult. It's the algebra of distributing and isolating variables and GCFs and undoing times with divide and being able to see all those things without being told, now do this, now do this, now do this. That makes calculus tough. Yes?
Where did the +1 come from?
I was just showing them the scoring. They got 1 point if they had this, the calculus part, and then they had to do all the algebra right to get the second point of that question. I just helped them see the scoring on it. So anyway, you don't have to worry about that, and I'm not trying to scare you out of calculus. I'm trying to show you that you should not be dismissive. If you see this and you think that's just insane, there's no way anyone ever does that, that's exactly what you will have to do sometimes should you move on to calculus. Almost identical steps there. So
Will our quiz have something like that, or what are our tests?
if it's on here, it's possible, yes. Okay. Do you guys have any questions about the process for 22? Anything you want me to explain what I did from one step to the next, or how I knew that? Yeah.
I like found what the numbers were.
Okay.
And then did everything, and I got the same thing.
When you say you found the numbers, like
I
you...
found tangent of 14, and then I used that.
Okay, but when you use that decimal, you need to make sure that you're using the exact decimal. Don't round it to like 3 decimal places. In theory, if you keep up with that exact decimal, you did the same thing that I did. But you're going to be hitting more buttons on your calculator, so then you run the risk of having a mistake that way too. But in the end, it ended up being the same. Yeah, you got something?
Oh, yeah. Could we just find all the angles of the purple triangle?
Okay.
And,
You
like,
could if you wanted to, sure.
try and correlate that to the red triangle to find E.
Go for it. I don't think knowing these other 2 angles are going to help you know anything about the sides. Sides, you need Pythagorean theorem if you have the right information, or a SOHCAHTOA equation. One SOHCAHTOA equation is going to have 2 variables. This SOHCAHTOA equation has 2 variables, but if you have 2 equations and 2 unknowns, substitution like this will at least get you the answer. It's not the friendliest question, but it does work. So okay, then let's move on to the last one. This one is not nearly as hard as the last couple, but I do want you to try this one. So take a couple minutes, try to draw the picture for 23, and I will share the answer with you. Or at least one of the answers. can't cancel out turns. If I do this, this is really supposed to be 1/2. Right? But if you let terms cancel, you're going to think it's 1/5 or something different. If these are being added or subtracted, you can't pretend like this is over this and ignore that this is also. Okay, let's check your picture here and see there is an alternative answer that would also work here. But your ship is 45 miles east and 30 miles south of port. So I think the most common mistake on this one is switching up which point is your ship and which point is your port. So you should label them. But your ship is 45 miles east of the port and then 30 miles south of the port. And then if I double check that, the ship is east and south. Not that the port is east and south, the ship is east and south. And the captain wants to sail directly to port, so that makes sense. That's the most efficient. Here's our right triangle that we know is supposed to be in there. So you can go about finding this angle the same way you did questions 1 through 15. You could do inverse because it's an angle, tangent because it's opposite over adjacent, and that is going to give you 56.310 degrees. But this can't be your answer. This is not a bearing. That's just an angle. So you could say from the north line, turn 56.310 degrees to the left, which would be towards the west line. So that's why that's one acceptable answer. And then another acceptable answer, I really don't know why students even do this, but this is technically correct too. If you want to draw in a north, south, east, west at the ship, if you know this angle is 56.310 degrees, you could find this angle if you wanted to. It would be the complement. These make a right angle. And you could figure out that this angle is 33.690 degrees. And then you could say from the west line, turn 33.690 degrees up, which would be towards the north line. Both of those are fine. I'm only looking for one on the quiz, but the only reason why I don't understand why you guys do that is because it's more work. Like, why are you doing more work and running the risk of missing the question? Just answer it the easiest way you can. Okay, any questions about that one? Okay, so a couple things before you pack up. I know I said this at the start of class, but our quiz next time, about half of the quiz, so somewhere between 2 to 4 questions, will be like questions 1 through 15, where we want you to find a side or angle of a right triangle, just a generic right triangle, not little to no real world context. And then about half of the quiz, 2 to 4 questions, will be like some of these word questions. So this flagpole type of question where you had to subtract a couple links could be one of them on the second half of the quiz. Making a picture or inverse tangent could be on there. A question like this where you might need to be careful about the actual radius length, or sketching your triangle and realizing that if you want your answer to be a length, you need the other sides of your triangles to be lengths too, not speeds. Same with number 20, except you also need to be able to draw a bearing. Some of that stuff also rolled into 21, but in 21 you needed one more angle, so we needed that old geometry thing. In 22 we had to solve a system of equations, so that's possible. And 23, I don't know that's different than some of the others, but about half of it is generic triangles like 1 through 15, and half of it is questions like after 1 through 15. So while this is fresh in your head, you should probably mark the questions that you should benefit from looking back at. So I would say for most of you guys, that's going to be 21 and 22. Those are the two hardest ones. But if there's a couple other of those that you need to review, you should probably mark them so you remember which ones you need to look back at. If you realize your mistake, like on number 18 was just this, you probably don't need to rework that question to be prepared. But you know what you need to do the best. So, okay, and then finally, I will ask you to turn this into Google Classroom. This is the only assignment that I have for you in section 4.8, so I will ask for it for some participation points. So if I was you, I would go ahead and turn it into Google Classroom now so you don't run the risk of losing it or forgetting to later, but that's up to you. I need that before we start the quiz on Thursday. Also keep in mind that this unit is only 2 sections, so 4.7 is typically the harder one for students. I will be giving you that quiz back soon. We've still got 2 more makeups for that quiz though, and then the other half of your next test is section 4.8. So you want to feel as good as you can about these question types for that quiz, because it should directly impact you right after that for preparing for the test too. Okay, that's all I've got for you, and you guys still have almost 15 minutes, so maybe turn that in, maybe mark the questions you need to study, maybe even practice 1 or 2 more of those, and if you have any specific questions, then please bring it up and let me help before you go.
On that